Alright, continuing on with our third in the Matlab editing of fuzzy inference systems video tutorials. Let's go ahead and show how we can modify this rule system. What we could do, we'll go through and we'll modify both the rule system and the membership functions. So let's go through and let's change the slope membership functions. Right now this is using slope and slope percent, and one could argue that, well, if I've got some really steep slopes, percent slopes could be calculated well over 100%. Actually, they could be 100 on up to, you know, even over 1,000%. And so right now the range of this slope is not very high, and so we can change the range by just adding another 0 here and upping that to 1,000. Now you can see what happens when I do that. It just stretches, when I change the range, it stretches all these other membership functions up, right? And so one really important point is if you want to change the range, make sure that's the first thing you do, or that you remember what the low values were first so you can go back and edit them. Because we went up by a factor of 10, it's going to be easy to edit these back down. And I'll show you how. And so if I want to change that range and then edit these membership functions back down, it went up by a factor of 10, so this for the low should be 5 and should be 10, and that's going to change the vertices on that. And then if I change the vertices on this to 5, to 10, to 15, and then to 20, then that brings the medium down, and then on this one it's going to be 15, 20, 100, and 100. Oh, actually, I'm sorry, we'll keep those at 1,000 because we do want that to go all the way out to the full extent of the range. And so now it's really hard to see this because I have such a large range. So if you have a fuzzy inference system with inputs and the inputs are outside the range, it just won't calculate a value for that particular cell. So it's important to make sure that you choose a range that's appropriate up front. Let's take a look at point density. Point densities for different types of surveys or in different settings, what we would consider low, medium, and high point densities will vary a lot. So for ground-based total station or GPS surveys, it turns out that, you know, typically anything on the order of, you know, over a point per square meter, you pretty much call high. And so here, and 5, you're rarely going to get more than 5 points per square meter with most total station or GPS surveys. And if your circumstances are different, then you want to change that range accordingly. In the medium and the low, it turns out that, you know, sort of typical high for sort of what we'll call high resolution ground-based surveys using total station or GPS, anything upwards of half a point per square meter is good. So we're using that as a medium, and then low, we're calling anything kind of below, you know, 0.25 points per square meter. And so the way these membership functions work is that you have overlap between the membership functions. We went through that previously. And so if I wanted to switch this from, say, a GPS to maybe using something where it's easier for me to get a lot higher point density, like let's say a multi-beam bathymetric survey, you know, in that context, I could have upwards of, you know, 100 points per square meter. So I'm going to change this out to 100. And, you know, low would probably be anything that is below, let's say, you know, 1 point per square meter for sure, and then we'll go maybe up to, you know, 3 points per square meter. We'll overlap that one with medium, and so if we change this to 1 and to 3, and then we change where we're going to have our next overlap, you know, it's probably somewhere up around the 20 and 30 range, let's just call it for now. And then if we change this one to 20 and to 30 as well, now we've got a totally different point density membership functions that we're using here to describe this. And so it doesn't actually matter exactly what these are so long as whoever's making the rule system understands what those ranges are and that those ranges are appropriate to whatever inputs you're dealing with and the survey technique you were using. Same can be said for the elevation uncertainty, and it's very important that you understand how these output elevation uncertainties are set up, and that this range is calibrated to what is a typical error distribution for your survey method. And it's going to be both the survey method and the interpolation technique, which interpolation technique's going to roll into it both your grid resolution and whether you're, how you're tinning these surfaces, whether you're using break lines, etc., etc. And so these values should be calibrated on a case-by-case basis. We're trying to develop a library of fuzzy inference systems that are reasonable rules of thumb for different survey techniques, but we haven't included that yet because we're still testing it in this version of the software. We're hoping that GCD5 will include that library, and then you'll have a place where you can start from, and then you can go in and tweak these if you decide. But if you used that library, it would be a reasonable sort of rule of thumb to work from. So that's how membership functions are edited. If you get that where you're happy, you can just export that to a file and save that, or when you close this down, it's going to give you the option to save the changes to this file, and then you can do that. I want to check one more thing before we move on, and that is our rules. Just to show you, we've already gone through how the rules were set up, but how you actually specify rules is you just select the combination of inputs down here. So if I wanted to use medium and high, for example, and then you just say what the elevation uncertainty should be with those. And you go through, and when you have the rule that you like, you just hit add rule, and it puts it in. And you'll notice that even though we have this same combination of medium medium slope and high point density up above here, it still lets me make a new rule. And so it's you have to be careful that you don't duplicate rules. The system will let you. It doesn't make a whole lot of sense to do that, though. You can change the connection for rules if you want. You can use ORs instead of ANDs, and that is something that in some situations is useful. You can also change the weight of an individual rule, and by changing the weight, if that rule applies for a particular combination of inputs, if there's multiple rules that apply, then it will give more weight to the ones that are closer to 1, but you could give numbers less than 1, for example. If I've put in a rule like this last one here that I don't like and I want to change it, I can highlight the rule and then change the values and hit change rule, and then it will change it. Or I can highlight it and hit delete rule and get rid of it altogether. So it's a pretty simple little system, and you combine that with your rule viewer and you can see how your edits make a difference. And that's basically all you need to know, all you need to know to be dangerous, at least, about how to edit the fuzzy inference systems. I really strongly encourage you to read the documentation on this if you start getting more involved and start making more fancy fuzzy inference systems. That's it.